triangle. This is the basics for supervised learning. The supervised learning again broadly classified into two. One is regression, another one is classification. If our output is in continuous values, let's say if we are going to predict a salary of a particular person, let's say based on the feature like his age, his marital status, or his qualification, or whether he is currently employed or not, his well, let's say his monthly expenditure. So these are all the features if you are having, then our system is going to predict average salary of a particular employee, or whether a person owning a car or bike or mobile. So his house, in his or her house, whether they are having two-wheeler, four-wheeler, or what is the vehicle they are using for commute. So based on those data, whether we are going to predict an average salary, the average salary is whether if it is in 15,000 or 20,000 or 5 lakhs or 6 lakhs per month. So that kind of if our output is in continuous value, then that will be comes under regression supervised learning model. Whether if our output is in comes under classification or categorical output, whether in this case whether the given input is a square or triangle, or it's an hexagon. There are only three categories. So if our output is a categorical model, then we are go for classification models. So for example, here advertisement and sales. Based on the advertisement feature, we are predicting the sales. So if we are having 90 advertisements, then our sales is 1000. So likewise, we are having the data, and from the data we can predict the relationship, right? We can go with either find the linear regression, linear relationship between the input and output. So based on that, we can identify the sales if the advertisement is $200. So in that case, our output is in continuous value. So we are going for a regression model. So that is a basic for supervised regression classification. The major terminologies when we play while we are working with regression models are dependent variables and the independent variables, outliers, underfitting and overfitting. These are all the two important terminologies while we are talking about the machine learning performance. One is underfitting and another one is overfitting. What is mean overfitting is if our model is always predict correctly when we are using our training data set, but it is not predicting correctly with the testing data set, then that is called as overfitting. Our algorithm trained only with the testing data sets, and it is not efficient while we are talking about test data sets, then that will be overfitting. Underfitting is our algorithm is not working well in the training data set, whereas it is classifying or predicting correctly or more accurately in the testing data sets, then that will be called as underfitting. These two should not be there. Our algorithm should not go with either underfitting or overfitting. So it should be nominal in the both the training data sets as well as in the testing data sets. The performance has to be in the same way. For example, in our training data sets, it is classifying 90% accurately. Then our testing data sets should also, our aim has to be make that testing algorithm in such a way in our testing data set also yield 90%, more than 90% of classification accuracy. So for as I said, for the classification, either our output value should be any of the categorical value, either the class A or it should be in the class B. So that is called as classification. For the linear models, we can go for logistical regression or support vector machines. For non-linear models, we can use k nearest neighbor, navy base, decision tree, and random forest classification. In the regression itself, we can have more large number of regression. For example, if our input and output maps in a linear line, which means our output and input maps on the particular line, then we can go for linear regression. Our line is a polynomial, fits in the polynomial curve, we can go for polynomial regression. Likewise, we can either go for support vector, decision tree, random forest, or logistical regression. Here I am just going to demonstrate only few machine learning models. So just to brief it. For the support vector machine, the main aim of support vector machine is to map the maximum data points within the boundary lines. That is what the main aim of support vector machine. So we have to have a kernel plane, hyperplane. With that hyperplane, we have to we have to draw boundary lines with sigma values. So in such way, if we are going with our support vector aim is to maximum plots inside the boundary lines. That's what the main aim of support vector machine. So in that way, if you are mapping all the points inside the boundary lines, then the boundary line will be moved far away from the hyperplane, and it is not preferable for the better algorithm, machine learning algorithm performance. So the performance will be if you are mapping all the data points, which is also not yielding any performance, or it is not going to support our classification accuracy improvement. So the support vector main aim is to minimize the boundary lines, and within that one, how to accommodate more number of data points. So how we can place the kernel or hyperplane, and how we can fix the boundary lines. These things will be uh, handled in the support vector machine techniques. As we know, in the decision tree and random forest, in the decision tree, what we will do is we can build a binary tree in which if we are, let's say, if we are taking which feature as the root node, then our classification will be perfect. Let's say we are having either of four features. Within the four features, if you are having the feature 3, then that feature will be classifying the given data with 95% accuracy. In feature 1, it is 80%. In feature 2, it is 70%. In feature 3, feature 4, it is in 10%. That case, we can take feature 3 as the root node. Then only our classification accuracy will be improved, right? So for that, to compute a classification of to pick a particular root node, we have to identify the we can either go with different mathematical calculations or Gini index or computing the probabilities. So all those things will be based on that. We can based on the values we can let's say we can build a binary tree model, and the decision tree will be used when we are working for the testing. Once the model is built, then that will be used for evaluating the test data sets. Uh, that's the things we have seen in the supervised model. Whereas in the unsupervised model, what we will do is here we are having only sample data, no labels, no class labels will be given to the. So the training provided to the machine learning with a set of data that has not been labeled or classified or categorized. So how your unsupervised model will be worked is it will take first data from the sample, then that will be compared with the next data sets in the sample data, and it will find the correlation, or it will be find the similarity between the two objects or two data entries, and it will be find whether how much it is relevant to the first two data sets. So likewise, each data sets will be compared themselves. Then based on the similarity and dissimilarity, this will be either clustered or grouped. So the restructuring of input data into a new feature or a group of objects with a similar pattern is called as unsupervised learning. For example, in the input raw data, we are having different cat and dog, but we are not providing any sampled input. So our model take the first cat and it will compare with the next dog, and it is fine that the shapes are mismatching based on the feature extraction. The features are not matching or it is quite irrelevant. Then it will go for another data from the uh, raw input, then that will be compared with that feature will be extracted, then that feature will be compared with two already existing features, and it find one entry is matching with it is quite relevant, or difference between those two entries are minimal, so it is considered as these two entries are cats, or these two are the one group, and the another dogs are dog two entries in the dogs are find themselves are similar, but these two among cats and dogs, the similarity is very low. So it is grouped into different categories. Then that will be the output. So here there is a no class labels. So the nature of the output of our system, if we are not knowing exactly what is the output of our system, then we can go for unsupervised learning. In the unsupervised learning, we are again classified into two. One is clustering and another one is association. As we know, clustering is it's an important concept in the unsupervised learning. The main aim of clustering is high the intercluster similarity and low the high intra-cluster similarity and low the intercluster similarity. This is the baseline for the clustering, which is nothing but similarity between the points in a particular cluster. Let's say in the cluster A, all the data points in the cluster A should have highest similarity. That is high the intra-cluster similarity. Whereas data between cluster A and the cluster B or cluster C, the similarity of these two data points should be low. That is low intercluster similarity. This is the goal of clustering. The clustering we can either go for hierarchical clustering, k-means clustering, or k-nearest neighbor, or we can go for PCA, principal component analysis, or single value decomposition, or independent component analysis. These are all the things comes under unsupervised learning. Whereas in the reinforcement learning, this is a third category of supervised machine learning techniques, where here we are not having, let's say, here the system is kind of feedback and reward system. This is nothing but we are designing a particular agent where that agent will be given to the environment, where that agent will play in the environment, and it will find whether for a particular action, what are the actions that agent is taking. Based on that each action that agent will get either a reward or it will either get penalty, which means if action taken by the agent is correct, then the system will get a reward, then that will be stored, that action is correct action, that step will be allowed. Whereas if for a particular action the agent gets penalty, then the agent will learn itself that is not the path it has to be choose. So based on the rewards and penalty, the system, the reinforcement agent will learn and the model will be trained in each and every action. So this is the way reinforcement learning will work. The main aim of reinforcement learning is to get the most rewards and minimize the penalty. There shouldn't be any penalty. The only action is it has to maximize or get more rewards points. That is the way the machine learning, reinforcement learning will work. For example, as I said before, the Tesla cars are using the reinforcement learning techniques, right? So here, the agent will be given to the environment where in the first picture in the slide, where the system, the car is moving straight, then there is a barricade, it is hitting the barricade, then the system will give the penalty to the car, which means the agent will learn that this is not the path we have to choose, which means there is a feature, there is a road, there is an obstacles in front of the road, then that path which should not taken. So that action will be recorded or it will be fed into the system, and the reinforcement learning, if a particular action is given a penalty, then that action has to be revert back, which means the car has to be come to the previous state, which means the as in the picture one, it has to be come back. Then it has to be identified what are the alternate solutions available. Then from that state, it identifies there is an alternative path. Then it is going to take that path. If that path, if it is correct, it is getting reward. Then it is recorded that this path is correct path. So likewise, this iterative process keep on goes until the system is, well, let's say the system is learned all the feasible or all the possible events or features or, well, let's say all the possible occurrences of a particular environment is learned, then the iteration will be stopped. Likewise, this reinforcement learning algorithm will be worked. Let's say we have seen different types of algorithm where we can use. For, as I said, supervised learning, either we can go for regression or classification based on the output data. For the regression, let's say population growth prediction, yeah. If for India population growth in 2020 or in 2010, if it is this one, 2020 is this one, then what will be 2024 or 25? That is a prediction. The output will be then numerical continuous values. So population growth prediction, market forecasting, weather forecasting, advertisement popularity predictions. These are all comes under regression supervised learning. Whereas in the classification, customer retention or image classification, identify the fraud detections. These are all comes under classification supervised learning. Whereas in the unsupervised learning, we can go for clustering, as I said, for clustering targeted marketing, recommendation systems, customer segmentation. These are all using clustering. Whereas association or dimensionality reductions, what we are go for unsupervised learnings are feature elucidations or structure discovery, big data visualization. These are all comes under unsupervised dimensionality reductions applications. Whereas in the reinforcement learning, we can go for game UI or skill acquisition, learning task, robot navigation, or real-time decision makings. These are all the areas where reinforcement machine learning will used. So far, we have talked there and there, then and there, training data set or test data sets. Then we have to know what exactly the data set. So how we are process a particular data sets. So for that, let's say our data sets might have my data sets might be either structured or unstructured. It might be any form, like it might be images, audios, videos, text files, or it might be in any cloud database, or it might be any traditional let's say it's in any data servers, or it might be any, let's say, even in the Excel sheets data which we are having ourselves, or any uh, SQL servers, or data will be received anywhere in any forms. It might be in numerical values, or it is in string in values, or it is in binary codes, or data will be in any form. So once we are gathering all the data in once the data pre-processing is done, we have to get an unified form of data that has to be in a particular structure. So once that, in the machine learning, how we will handle the data set is, when we are train a model, we won't use the actual real-time data. Why? Because in the actual real-time data, we are having a huge number of data. Data size is very huge. Then with that, we are not able to process our system, because we are design a model. We are not having enough processing capacity. We don't need to have it actually. So for that, we are, hello. I'm having some background noise. I'm getting some noise. Is anybody uh, can mute somebody is unmuted? Excel BCA. Yeah, thank you. So for that reason, we are not going to use the real-time data for modular systems. So for that case, we have to use some freely available data sets to design a model. How we are having a real-time data set is, either we can go for data sets providers, where a lot of data sets providers having huge number of huge categories of data sets with all the real-time possible combinations of a particular business problem. So we can either go for freely available data set providers, or either we can define our own data sets. So once that we are getting the original data sets, we can either go for same data sets both for testing and training and testing. We can either use the same data sets, or we can have one data sets for training and another data set for testing. But mostly in the practice of machine learning designing, what they will use is the original data sets will be baked into where 70-30 rule, which means 70% of data will be used for 70% of portion of data in the data sets will be used for training, and the remaining 30% will be used for testing. So in the training, 70% of data in the training set, which will be again uh, class, divided into two groups. One is actually used for training datasets, and another one is used for validating the predicted model. One or prediction model given the validation better performance in the validation set, then that model will be given to the remaining 30% of testing datasets. Then our predicted model is working fine with the testing datasets. The performance is estimated, then that is satisfactory, then that will be the model will be accepted, and it will be given to the real-time data sets for the prediction or the classification. As I said, either we can go for own datasets or we can take the datasets from the dataset providers. There are huge number of datasets providers are freely they are providing in the purpose of education and the research in the machine learning algorithm designing. So I have just to list out a few datasets providers having huge number of datasets, Google datasets and UCA machine learning repository. So let's say machine learning repository, UCA machine learning repository having the datasets pertaining to regression classification and clustering, which means for datasets which is predominantly used for machine learning, which will be given by UCA machine learning repositories. Which means what is the difference between Google datasets and the machine learning regression machine learning repositories are Google datasets having datasets which supports both for data science or machine learning or huge all the categories, whereas UCA machine learning supports specifically for machine learning. What is the difference is for if it is example we have to test a regression model. Our data sets should be a column of which means targeted column value should be in the continuous value, right? So if it is a classification, the targeted column might have any categories. So clustering should be more than two categories or one category. So those things will be uh, specifically given for machine learning that is supporting by UCA machine learning repository. Actually, we are Orange itself using the Irish datasets, which is famously used for let's say machine learning. Uh, uh, let's say for the educational purpose or for the better understanding. Mostly, we will use Irish datasets, which is provided by UCA machine learning repositories. Whereas for Google Datasets Engine or Microsoft or government datasets also, government is also providing datasets. For example, uh, let's say if you are working with number of colleges, or you have to explore the data for a particular universities or government institutions or number of patients or number of let's say number of projects given by a particular government or particular period of time. All those things will be given in the government datasets. So either we can go for US datasets, the www.data.government, which is the US datasets, whereas UK datasets, data.gov.in is an India datasets. So these are all the mostly there are few more datasets, but I have just listed few things for computer vision datasets. This is an image classification datasets. If you are working on images, then for image processing things, you can go for computer vision datasets. So likewise, for every category, we are having more number of datasets providers. So we can use that datasets providers and we can predict our model. Because these datasets are already, let's say, pre-processed and readily available for us to use. So we no need to waste our time for data gathering or data wrangling. So all those things we no need to spend our time. So up to now, I just briefed some basics of machine learning. Now we can go for Orange tool and how we are implementing or how we can utilize Orange tool for the machine learning algorithm design and how we can predict or classify the models. We can let's start here. Orange tool. Um, let's say what is Orange tool? Orange is an open source tool which is actually a visual programming software. It is a kind of C#.NET. It's a component kind of library. It is already having number of components. We can just drag and drop all the components available in the tool, and we can do the stuff. Which means, let's say, if we have to read the data from the file, how we have to do either in the Java or Python. We have to write the file operations. We have to read the file. We can take the data and we have to display, or we can write it in the another file, or we have to store in the database. So all those things we have to write a program, right? So here in the Orange tool, we no need to do the any coding. Actually, for the we can with 0% of programming, we can do let's say almost all the machine learning classification and prediction algorithms, which means supervised and unsupervised learnings we can do without any programming, with 0% programming using the Orange tool. That is the biggest advantage of Orange tool. Why? Because let's say if I am a Java developer, I no need to, I have to learn a machine learning algorithm, or I need to predict, I need to develop a particular model, but I no need to spend my time to learn Python, because Python have a huge number of libraries supporting for data analytics and machine learning, right? Compared with Java. In Java also we can do, but in easily we can do with Python. So again, I don't need to spend my time with Python, learning a Python instead of learning a machine learning. So for that, I have searched tool without any programming. That way, I have landed up this tool called Orange, where I don't need to learn any coding. I can easily do all the things whatever I want to do. So it is an workflow driven pattern, which means workflow driven is nothing but uh, uh, I can, as I said, here there is a components here which are all called as widgets. We can just drag and drop the widgets, and we can make a workflow with to solve a particular problem. For example, for the classification or for the predictions, we can just drag and drop for the file reading one widget, for the data pre-processing another widget. Once the data is pre-processed, either we can go for ranking. So once the ranking is done, either we can go for classification. So for the classification, I can either go for tree viewer. Once the tree is used for classification, then I can view the data in the tree viewer. So likewise, I can train a model. Once the model is trained, I can use another file input, and that will be given to the system as test. So for the testing, for that we can go for test and score widget. Once that's done, this entire thing is called as workflow. So if I have changed anything in the one widget, which will be automatically populated or automatically reflected in another widget, which are all connected to the particular widget. That is called workflow driven pattern. For example, initially I have designed a system with one data set, and after the designing, I have to change the data sets. So once I have changed in the file widgets, which means input file, the all the subsequent widgets will be automatically auto populated, which means auto workflow driven. Then my analytical results will be varying. That way it will be workflow is driven patterns here. Let's say, as I said, why we are go for Orange tool? No need to programming. Yeah, one more biggest advantage is we can data presentation is data presented in a visually, which means we no need to go for view all the data in the Excel file, or if we are having 2000 entries in a data set, by visually we can see without in a raw format is not a good thing, right? So using the Orange tool, we can just visualize our data in a different format. For example, straight away I can take the data and I can pre-process it, or I can view it in the scatter plot. So with that scatter plot itself, we can I can change the axis and I can find that how the data are formulated. how the relationship between one feature and with another feature. So all those things without manually analyzing the data in the Excel sheet or the data file. Instead, I can use the widgets available. So the widgets will help us to visualize in the pictorial manner. So which is very easy for us to analyze and easy to let's say easy to come in a conclusion, right? So data visualization is the biggest advantage in the Orange tool, and it is support a multitude of machine learning algorithms. As yeah, I said, there are almost all the major supervised and unsupervised algorithms are available in the form of widgets, so we no need to write a code for a particular algorithm. Either we can straight away use it. So in that way, it is allowing us to do the classification or clustering. And one more thing is, as I said, it's an open source, so it's a free of cost. So that is the biggest advantages of Orange tool. That uh, here, let's move to install the Orange tool. How we can do the installation? There are two kind we can do. Either if you are already a Python developer or you are already working on Python Anaconda Navigator, which means Anaconda is a framework where it is having tools like Orange, R tool, or Notebook, Jupyter Notebook. This is an Python editor. So all these tools comes in a package called as Anaconda Navigator. If you are installed Anaconda Navigator, you can install the Orange tool using the Anaconda Navigator. If you have installed Python uh, using the pip command, you can install Orange. In the screenshot, we can see through the pip. I have used pip install Orange 3, pip install Orange 3, which is used to install Orange tool as a standalone application. Whereas in the Anaconda Navigator, if you are having Python available as a package inside Anaconda Navigator, if you want to install, either you can straight away click the install button and it will be installed inside the Anaconda Navigator. So we can both way we can use. I have for this session I have used pip install Orange tool. I have installed Orange as an independent package. So with that I am going to demonstrate the next sessions. So I, as I said, see here I have installed Orange as a separate package. So I got Orange. So let's start with just overview or what is meant by widgets and all those things. As I said, all the components in the Orange are termed as widgets. I said right, widgets. That is these things. Let's say a file, which is a widget. File is a widget which is used to take the or it is used to read the data from the files or data source. It might be either a file or it might be any URL links or it might be any Twitters or any web links, or even if we have any local files or anything from file we can, or any data sets we can take it from any or read any data sets, or we can use any URLs. So all those things using the file widget we can read. So once the URL are given to the file widget, then that will be going to that URL and get the data in that URL. Or if you are going for any data sets, the values in the data sets will be straight away taken. So this is a widget which is used to take the value from the widget is used to read the files. So these all components are called as widgets. Uh, just a moment. Just a minute. This is called as widget. Uh, the data is a category. This is called as category. Inside the data category, we are having the widgets which is used to operate on the data. For example, file widget or CSV for import a particular CSV, we can go for CSV import. For a particular data sets, we can either use the file widget to read the dataset, or we can go with dataset widget to read a particular dataset. For read a datasets alone, we can go for SQL tables to read the SQL datasets. Likewise, data tables or print, or we can go for select columns, select rows, pivot tables, rank, data samplers, or transpose. These are all pre-processed. The data pre-processing operations will be used a widget called data pre-processing, or either we can go for impute or feature construction or feature statistics or save data. So these are all the widgets which is working on the data category. So this is called as widgets. Before that, this is the pan which is in the white right hand side, which is in the white in color, which is called as canvas. So in this canvas only we can use the widgets and we can create a workflow. I said workflow, right? So workflow is nothing but, for example, this is called as workflow, which is nothing but a read from the file and visualize the data in the scatter plot. This thing is called as workflow, where the links between the file and widget is the pipeline where the data is flows. For example, this is the data flow view. Either all the data in the file I can give to the data scatter plot data, or I can map that all the data as a subset of data sets. So subset means either I can selected values only I can give, or few values are fed to the system as a data sets. So those things will be given. For example, I am going to visualize, as I said, iris data set, right? So if I'm taking the iris data set, so let's say before it was dotted lines. Why? Because there is no input for the file. So now once the data is given to the file, the data is auto populated to the another widget. This is called workflow driven. Once the values are fed to the system, then automatically the values are changing. So this way we can visualize. As I said, right, we can easily visualize instead of seeing, let's say, iris datasets how it is look like. Let's say this is the iris datasets. So the data have 153 entries, which has a sepal length, sepal width, petal width, and iris. It is a classification. So these are all 5 columns available, and each columns are tab separated with only values: 5.1, 3.5, 1.4, 0.2. So instead of visualizing these values manually, it is very tedious, right? While we seeing these values, how we can predict, how we can get it. So instead of seeing like this, we can see like visually. It is more informative, right? All the data are mapped, plotted in a particular graph with sepal length and sepal width. We can change it. Either way, I can change petal length and petal width. For example, sepal length and petal width. If I map like this, the data points are resides like this. So with this only, we can easily say that our classification should be based on either which is the feature more accurately classifying. So here see, while seeing this for a particular data point, it is giving that sepal length is 6.1, petal length is 4.7, class is iris virginica. So features are based on these features only it is classified. So these are the things we can, without having any code, we can easily do with our. So for example, if I like this, petal width and petal length, the classification is like this. So we can uh, the visualization will be done easily. So as I said, this is called the right side. The white one is called as canvas, where we can use the widgets to create a workflow. Workflow is nothing but which is an solution, or which is an let's say, which is an set of sequence of widgets connected to solve a particular problem or particular aim. So this workflow aim is to visualize the iris datasets. So as I said, workflow driven. Once if it is an iris datasets, I'm going to change. You can parallelly you can see the different things. Instead, iris datasets, I'm using Titanic datasets. Her heart disease datasets. So, man, once I have changed the datasets, automatically the widgets, widgets which are connected to the file datasets will be automatically populated, and the results will be changing, right? For example, if again I am going with iris datasets, see the values are changing. So this way, all the data are all the workflows are data driven. So one change in the one widget will be automatically populated to subsequent widgets. So these are all called widgets and workflows. This is called data mapping, how we can do. And these are all called as categories. As I said, for data, we can go or either visualize, which is a category, which is used, which is having widgets, which are all used for the classification. So that is called visualization. Or for model, what are all the mathematics machine learning models already available, we can have it. Either we can go for logistic regression or SVM or a random forest or tree, KNN, clustering. For the evaluate, we can go for matrices like confusion matrix, ROC curves, which are all very much informative. One while we are go for computing the precision recall and FMSs, right? So all those the prediction widget is used to predict values. So test and score is used for let's say classification. For the classification, we can go for test and score. For the widgets which are supporting for unsupervised are comes into the category called unsupervised, where k-means, hierarchical clustering, DP scan, distance, principal component analysis widget, so distance matrix, distance file. So these are all the widgets supporting unsupervised. This is called categories. Okay. So initially, once we are installed with Orange tool, we can't able to see all these widgets. Only bare minimal widgets like data, visualize, model, and evaluate, unsupervised. Only these widgets only available. So how we can get all the remaining widgets is we have to manually install it. Manually means there is an option in the widget. In the screen options, if we go for, there is an tab called add-ons. So once click add-ons, for this you have to open the Orange tool with administrative privilege. So let's say I'm going to open with administrative privilege. I'm going to give run as administrator. Okay. Actually, this is the welcome page of Orange. I will explain this one and I will go for options later. Here, this is new window. Oh, okay, I have closed. Let's come with later. So once go for add-ons, here once it's opening, it will list out what are all the add-ons available. So we can, if we are working with let's say social media network, you can go for okay, If you are working with text minings or text classification or image classification, to work with image you have to install image analytics. If you are working with text you have to install text and textables. If you are working with networks you can go for net. If you are working with the geo specific, it's you are working with maps or latitude longitude, so those kind of things. If you are working with bioinformatics, if you want to install with associative, you can install it. For example, these are all the things in the black which will becomes as part of orange while we are installing, which means associative, bioinformatics, spectra, prototypes, and orange 3. These all will come as part of install itself. But if you want to install it, you have to select and okay, it will automatically install. For example, if I am giving a single cell which is not installed here, you can see there is a no category called single cell. So once if you want to install a single cell, so here itself we can see single cell add-ons add the functionality for analysis of single cell data. So which is gene filtering or pre-processing for gene expressions. For all those things, we can go for single cell along with bioinformatics. Okay. So if I want to install it, I have to select this action is install. If I click OK, then this add-on will be fed from the internet, which is nothing but, as I said, it is a tool developed on top of Python. So what it will do is it will install it will get the packages related to the single cell add-on, and it will keep in the orange installed directory. So we can just once it is done, that package will be available and we can use it. So likewise, we can install. For the time being, I'm canceling it now since we are not going to use single cell as of this demo. So likewise, I have installed what are the things we have to see. For example, for the text mining, if you want to work on text mining, I have installed the text mining where either you can go for social media analytics, you can either go for Twitter, or you can go for Wikipedia search, or you can for NY Times or The Guardian, or if you want to work on files, huge number of files you are having, you have to work read the files, data from the files, and you have to do classification of those files or analyzing the data on those files. Either you can go for document import, then you can pre-process it, and all those things we can go for text mining. So I will come all this one by one. So likewise, if you want to go for everything, you can, for each category, there is an distinct usage for each and every widget in the canvas. So as I shown, these are all data visualize, model, evaluate, supervise. These are all called as categories, whereas each component, each widget in a particular category is called as widget. It is a component. Then the white blank space on the right side, which is called as canvas, where you can drag and drop, and we can create a workflow and we can solve our problem. So that is called as canvas. As I said, as already I have shown, the widgets which are all used for data categories, file, CSV import, or data sets for SQL, or for data samples, or all those things. We can use these things for data. This is a really important slide where we are using widgets which are all supporting for unsupervised. For unsupervised, there is a separate category, so we don't need, we can use it. For supervised, the widgets which are all under the models are used for supervised learning. For example, linear regression or logistic regression, random forest, SVM, stacking, neural networks. So these are all KNN. So these are all used for supervised machine learning model widgets. Um, as I said, to evaluate the machine learning algorithm, already I have explained this. The data sets will be divided into two. One is for training and another one is for testing, which is 70-30 rule, which means 70% of data sets will portion of data sets will be used for training, and another 30 percentage will be used for testing, on which measure the performance. Um, Widgets for evaluate. Let's say, which is very important category we have to know. Evaluate. I just go through few widgets in the model and evaluate. As I shown, the models widgets under the model categories are used for supervised learning, right? Either tree or random forest or SVM, linear regression or logistical regression, KNN, Navy base, neural network. Here thing is, let's say one more thing I missed to address. These are all things the thing is, we are not coding anything, right? 0% of coding. So far, we are not writing any Python code up to just not even a print statement, echo statement, anything, nothing. Without doing things, all these things freely available. I just going to show the practical demonstration in the afternoon session so that you can understand the power of each widget. So here just I'm just explaining these are the widgets available. We can use these things and we can do amazing things in just a few mouse clicks. So that is the thing. You can closely see these two things. We can say these files and widgets which having dotted lines on its left, whereas neural network is a widget which having the lines in the both the sides, right? What it means, which means not the name of widgets. I'm just talking about the widgets which having single-sided line, either right or left dotted lines, or the widgets which has lines in the both. What is the difference? What these things speaks about? Thing is, if this is the widget yields only the output, that is the meaning of this line, which means we can't give anything to this file. We can just take output from this file. That is the meaning of this one. This file only yields the outputs, which means output from the files. It is not taking from any of the components which is available in the orange categories or orange canvas. From the canvas, it won't accept any of the widgets to be connected as an input. It is allowing only output and which is going to be connected as an input for another widgets. That is the meaning of this line. Whereas a neural network is a widget which is taking as input from another component and it is also providing output for some other widget component. For example, I am connecting file to the neural network. It is taking, which means file is an component widget which is supporting only output, whereas neural network is an component widget which is support both input and output. It is accepting the file output as its input, and it is also providing output either prediction or distance score. Okay, here, for example, uh, here it is a simple thing. What I did is I have just trained a system using neural network or file using neural network. That is the thing I have done just because only using three widgets and few clicks. For example, I have taken iris datasets. Okay, I have taken iris dataset. I am using neural network model to train our system. So for training and test and score, which is yielding by using neural network, my test has this is important parameters. AUC is area under curve, whereas CA is a classification accuracy, FMS is precision and recall. Okay. For example, I am using a neural network. My classification accuracy for the iris data set is 94%. See, without anything, without any code, nothing, I have simply do things and I have found that my data sets using neural network 95 for 94.7% classification accuracy I can get it. For example, likewise another model I can use. For example, I can go for Navy base, I can use test and score. For example, if I use the Navy base, see, if I'm using Navy based model, my classification accuracy is 87.3%. Got it? This is the way you can just do the just to drag and drop things and you can do it. For example, test and score itself having it yielding the output. Mm. You can for the confusion matrix, as I said, if you want to do the confusion matrix, which is very much important. So once for computing the precision recall or FMSS, or if in the research, if you want to present our data in the form of confusion matrix results, you can straight away take it. For example, you can analyze, you can feed your input data, and you can get it. If you want to save these results, you can just go here. Uh, in your leftmost bottom, you can have show widget help or report, or so in the report, if you click, it is saved as a confusion matrix. You can likewise you can save all the reports results. You can able to save it. Okay, uh, this this way we can do these things. And one more thing, to get the widgets in the canvas, the one way we can just double click, it will add as part of as part of in the canvas, or you can drag and drop it, or you can right click in the mouse right click, you can get the widgets from here. You can select this way, you can get the widgets inside the canvas. Okay, so for example, let's take test and score for file widgets. And one more thing, if you are taking any output of a particular widget, here it will show the all possible widgets which is taking file output as its input. So only those widgets will be listed here, so that you don't need to do the incompatible widgets connected. So which is not going to work. So for that, if you click the particular output and in the left mouse click and you leave it, here it will display. For example, here we can able to see almost all, but whereas if you click test and score, if you click test and score, you are getting features which are all confusion matrix, ROC, or paint, or few things, right? So let's say for the distinct purpose, I am going to, so here we can have scatter plot, whereas test and score, we have scatter plot. Or I'm going to show some other thing. For example, in KNN, output of KNN. See, only output of KNN accepting only widgets of type test and score, impute, Python script. See, save model, tagging, predictions. explain prediction. So only these things one will be accepting. So likewise, we can able to find what are the widgets supporting or what are the widgets accepting one widget's output as the input of another widgets. So these things we can able to see as part of left and right mouse click movements of particular widgets. Okay. Um, let's go for categorical components for a particular visualization. For visualize, as you know, scatter plot, which all these values you know, I guess, scatter plot or Venn diagrams or box plot or tree viewer or flatten plot, so nanograms. So these are all the visualization components. So which are all self-explanatory, whereas models of model categories of widgets of things are supporting only for supervised learning. Those things will be comes in the model category. Whereas in the evaluate, here there are two major things. Are one is test and score, another one is prediction. So prediction is used to identify the data which are all categorical values, whereas test and score is used to for linear continuous values. For regression kind of things, we can go for test and score widgets. Whereas these are all the important matrix, confusion matrix, and ROC curves. These things we will I will explain it with examples so that the purpose of these widgets we can get it. Whereas for unsupervised learning, as I said, for unsupervised learning, the major important widget is distance, right? What is the distance widget will do is the distance widget will identify the similarity between one widget to another, one entry, one data point, and with another data point, which means for clustering, identify the distance, which means similarity between one data to another data, and it will have a computation based on the distance only. The ranking will happen, which means either the hierarchical clustering or k-means or KMN or iterative clustering. Distance is the basic parameter, basic widget which supports for unsupervised learning. Whereas for prediction class, these things prediction is used for categorical, whereas test and score widget is used for uh, continuous regression type of values. Whereas if you talked about image analytics, the widgets used for image analytics are image import images, which is used to import the images. For example, it's kind of file widget to import file. CSV file import used for CSVs, or we can go for paint. It's used to get the data as a data points colored here and there, x-axis, y-axis. We can paint uh, draw points as a input. So for that we can go for this one. For SQL tables, we can go for get the SQL data input. So likewise, to import images, we can go for import image. For example, to import text files, we can go for import documents. Or if you are going to get the tweets, we can use Twitter tweet as a input reading file, input reading widget, which means see, these are all the widgets only having output. There is no input. So these are all the widgets having these are all the widgets used for input, reading the input. For example, uh, for social medias and all, there are a lot more. The Guardian or NY Times. For Wikipedia search, so for Wikipedia search and all, either we have to give just only what are the queries we are giving for the Wikipedia, and it will get the data from that particular thing. So for if you are networks, network file is the input. For geo, so for educational, we can have iterative k-means clustering, which is the widget used to explain how the clustering is happening. Which means each iteration we can adjust its timing and number of iterations, so that for the pictorial explanations we can go for iterative k-means. So polynomial regression and all those things. For the pictorial representative and explanation, we can go for the widgets in the educational. So bioinformatics, I am saying about I don't know any widgets. I haven't used any widgets in the bioinformatics. Those who are work on the gene expressions or medical data, probably they can familiar with these widgets. For associate frequent item set or association rule mining, as we know, that can use for determining things. So all those widgets are here. Spectroscope, yeah, to analyze an voice or to work with the time series data, we can go for spectroscopic widgets. So these are all the major categorical values of widgets and how we can use it. So in the afternoon session, we can have the practical demo session, so that one attested I can able to explain it. So there is a widget called test and score, where we can go for a sampling of values, the data sampling. I will explain it what is this data sampling and all those things now. With that, we can wind up the session. For example, test and score. As I said, how we are going to handle the training data set and testing data set, how we are going to classify the data sets, right? So for that, there are several techniques will be used. That is, I will explain what is meant by cross validation, what is meant by cross validation by features, what is meant by random sampling, what is meant by leave one out, what is meant by test on training data, test on test data. So all those things I will explain now. Orange tool is opening, it's taking some time. I think my system has, it's not opening. Okay, so I think I need to restart my system, so I will continue this one in the afternoon session. Uh, so far, if anybody has any queries, please. Um, Ma'am?
Sir,
Ma'am, I guess my system needs some restart, so I will continue with continue in the session, ma'am. If anybody has any queries, let me explain now. Otherwise, we can close it, ma'am.
I think there is no query session. We will continue.
Ma'am?
There is no query sir. So we will continue.
Ma'am, shall I close the session, phone session now?
Um, okay, sir. Shall we start? Will we start, sir?
You can say, ma'am. 10 minutes before I can start, ma'am, in the afternoon session.
Sir?
Usually 2 o'clock, right, ma'am?
Yes, sir.
Okay, ma'am, we can start 2 o'clock.
Okay, sir.
Thank you, sir.
Thank you.